Okay, 4 minutes is enough time, so this is gonna be rapid fire. The energy content is only constant during steady heat conduction because temperature is changing during transient. For the next question, the under drink would warm up faster because the blanket acts almost as an insulator, causing more resistance to heat transfer. For the next question, I did a sum of resistances, being the first one being convection, then conduction, then convection. And when I summed those all up, I got a total resistance of 0.041. And when I did the heat transfer, I just did the temperature on the inside versus outside over my sum of resistances, which got me 707 watts. And just did and since the heat transfer is like the same for the convective conduction and convection, I just set the total heat transfer to the convection equation and got that the inner surface was 4.4 degrees Celsius. For the next question, I said I summed up all the resistances doing a representative section of 1.1 and 0.65 meters, just because that's one wood panel and one fiberglass. And since those are in parallel, I had to account for that. When I summed up all my resistances, I got 6.59 Kelvin per watts. And then I multiplied that by the actual dimensions of the wall divided by the dimensions that I used and got 406 watts. For the next question, I did the resistance of the cylinder. And then I had to guess the temperature to find my heat coefficient for radiation, which I used for the second convection with a combined coefficient of the radiation post convection 2. When I summed up all my resistances, I got 0.0273. I did the differences of the temperature inside and outside divided by my total, which got me 2930 watts. And then to find the average velocity, I just did Q equals, or mass equals velocity times density area rearranged and got 0.186 meters per second. For the next question, I said that the thermal conductivity corresponds to the diffusion coefficient, the temperature gradient corresponds to the density gradient, and Q corresponds to the Q dot corresponds to M dot. For the next question, I said as I based it off of the resistance equation, so increasing the density of the wall would decrease the resistance, causing more mass transfer. If you double the thickness, it will not double the mass transfer. If you increase temperature, the mass transfer will also increase, which is true. And if you double the mass fraction of a diffusing species, that will not double the mass transfer. For the last question, I just did the diffusion equation and then plugged in my numbers, and I know that gave me moles per kilomoles per second. So then I multiplied by the molecular weight of hydrogen, which got me 2.3 times 10 to the negative 8 kilograms per second and 9.1 times 10 to the negative 9 kilograms per second, based off of the 0.002 meters and 0.005 meters of the length of the membrane.